Fireship, we love you. Thank you for bringing us the best content day in and day out. We're going to tune into this computation video because it's changed forever. Let's get right into it.
This is the world's largest supercomputer, El Capitan, with over 1 million CPU cores and 10 million GPU cores at its disposal. Some might call it blazingly fast, but Google just unveiled a new quantum chip named Willow that can fit in the palm of your hand and solve certain problems septillions of times faster than this future dinosaur. To put that in perspective, a problem that takes Willow 5 minutes to compute would take El Capitan this many years. That's more years than the age of the universe. Even if you had an El Capitan supercomputer for every grain of sand on Earth, powered by a Dyson sphere around the sun, it would still be many times slower than Willow. But the Americans aren't the only ones making breakthroughs in the quantum computing field. Just days ago, China introduced a record-breaking 504-qubit superconducting chip. After seeing this big number, people on the internet started freaking out because a computer this powerful could break. After seeing this big number, introduced a record-breaking 504
Develops record-breaking 504 qubit quantum computed. So for those who don't think that I know, or for those who really don't know, right now we're not on quantum computing. We process things on 4 bits, right? That means that the possibilities of getting an answer are only in binaries, 4 bits. Like you can only get the limited, I want to say it right, because I know I'm butchering it. You basically can only have 4 bits of possibilities. That's the best way I could put it. Like the chances of you answering is only in 4 bits, right? Quantum computing, I believe, is either 8, 16. The amount of bits that you're able to compute in, this one is 504 qubits, 504 qubits. Yo, look, I only know about more than four. 504 qubits, that means that there is 504 more possibilities and more ways to answer whatever fucking question you have, bro. 500 and more possibilities, bro. And mind you, we already operate on 4 bits, right? And this is what our computers are and how it answers. Look at how fucking good it does. 504 qubits on quantum power is ridiculous. You get what I mean? And for Google to say that that small little thing can compute what, 10 sextillion? Like that is now we're getting into like how fast can you get the information rather than what information you get in.
qubit superconducting chip. After seeing this big number, people on the internet started freaking out because a computer this powerful could break unbreakable encryption algorithms and steal all those Hawk-Tuah tokens that you just YOLO'd your life savings into. But that's ignorant. By the end of this video, you'll understand how quantum computing actually works and why it still totally sucks as of today. It is December 10th, 2024, and you're watching the Code Report. On one hand, quantum computing could lead us to a utopia that unlocks fusion energy, artificial superintelligence, and immortality with nanorobot doctors, but it also poses an existential threat to humanity. Computing at this speed means that unbreakable encryption algorithms are suddenly rendered worthless. Any hacker
Yeah, bro. Like if you have a password, just think of it like this. If you have a password, all right, it'll take me long right now with my computer to guess it. Give me a 500 qubit computer, bro. I'm guessing that bitch in 1 second, my nigga. Like all you gotta give me is more possibilities of answers, and it's over, my nigga.
with a quantum computer could instantly brute force your RSA encrypted communications on the internet, or worse yet, crack your wallet seed phrase and steal all your daddy tokens and NFTs. But despite Google and China making some big breakthroughs, this technology is still nowhere near being useful. To understand why,
You know what's sad though? The IT space is one of the spaces that's least talked about because if you tell a programmer you can make a program and I could just undercut you, a programmer is going to do his very best not to get that information out there and let other niggas know that, hey, look, hackers can fuck us up. So, like, in reality, every programmer should be well versed in hacking because it helps your system grow inevitably.
you first need to understand how quantum computing works. Classical computers, like the one you're using right now, rely on bits, binary zeros and ones, to process information.
All right, so you see 1 bit, 2 bits, 4 bits, 8 bits. You feel me? That I honestly the definition I gave was spot on because I never gave an odd number. We operate in bits. It's either 4 bits, 8 bits, but the larger it is, the more possibilities you get from a machine.
Each bit represents
and numbers can be translated into words. You feel me? So that's the only kicker. You looking at it like numbers, like what is this gonna do? No, it's gonna either crack an encryption, tell us what a message is, like decipher it, or do something that we aren't even ready to talk about yet. So
a single state, like a light switch, and you can combine them together to do complex things like stream this video around the world. Quantum computers also use ones and zeros, but put them in something called a quantum bit, or qubit. The key difference, though, is that they can represent the quantum superposition of multiple ones and zeros at the same time. Like, you can imagine a qubit as a box with a cat inside, and when you open it, there's a certain probability that the cat will be dead or alive, but you don't know until you open it. Mathematically, the equation looks like this, where A and B are probabilities, called amplitudes, that the qubit will collapse to a 0 or 1 when measured. And that means one qubit can represent a ton of information and compute in parallel. What's really weird, though, is that these qubits can become entangled, where the state of one qubit is directly related to the state of another, even though they're physically very far apart. And that weird behavior can be used to coordinate computations using quantum gates. They can do things like flip a qubit and create entanglement to provide a similar purpose to logic gates in classical computers, but do so by leveraging quantum mechanics magic. It sounds awesome, but the big problem is that qubits are extremely delicate, and they consistently produce errors, with some qubits having higher error rates than others, and that means they constantly need to deal with error correction to keep the thing stable. Not to mention, these chips need to be kept at temperatures near absolute zero to even work, so don't expect an Apple quantum phone anytime soon. Now, one thing that's special about Google's Willow chip is that it's able to find qubits with high error rates and reconfigure them on the fly, therefore reducing the overall error rate. And what's especially weird is that the error-corrected qubits get exponentially better as they get bigger, and Willow is the first chip to ever do that. Another big problem with qubits is that they need to be aroused into a state of superposition, and can only maintain that state for about 20 microseconds in the past, but on Willow they've increased it by 5 times, up to 100 microseconds. That's still not a lot of time, but Google's next big milestone is to build a long-lived logical qubit. Willow only has 105 qubits, but can still perform certain calculations, like finding the prime factors in a large number, much faster than classical computers. Algorithms like Shor's have been around since the 90s to do this, but we've never had the quantum hardware to actually run them. In theory, when quantum
can you imagine that? Shor's created an algorithm for a computer that didn't exist. Only humans can make that make sense. Shor's okay.
computers get to around 2000 qubits, they should be able to break widely used encryption systems
I believe there was quantum computing back then. I just feel like in reality, we went back to caveman times over time period, and we're now going back. It's like a reverse, like a circle of life. We're going to fuck up technology soon so much that we forget how to use technology. So we're going to revert back to our barbaric ways. And then once we revert back to our barbaric ways, we will become one and singular with everything around us. So we will make new forms of advancements and have technology all over the world that could do things that we never fathomed. It's all like a cycle, it's a loop. And I feel like right now we're just like in a specific part of the time skip or loop.
like RSA, using simple brute force techniques that would take classical computers millions or billions of years currently. And what's scary is that the Chinese just released their own quantum chip with 504 qubits. That's impressive, but the real thing to watch here is the error rate. Once the error rate gets low enough, we'll hit that inflection point that allows quantum computers to scale up exponentially and change the world in unimaginably good and bad ways. But this timeline has been all messed up since that fateful day on May 28th, 2016. And the best way to keep up as a developer is by hanging out with other developers on Daily.dev, the sponsor of today's video. It's a completely free social platform that curates all the best developer content on the internet and helps you connect with other like-minded people. Instead of
I always put it off Daily.dev because I want to get into that community more, be more involved in it. So we just gonna do it live. Start reading free forever. Oh yeah, for sure. For sure, for sure. Let me see, for sure, for sure. Add to Chrome, add extension, extension downloaded. Alright, you notice you decided to pass on the extension. I didn't though. Yeah, see that I have it. Alright, I bet. So for this part, I'm just gonna, hey guys, because I just wanna do my thing in peace without you guys having to see all that. But if you guys are sticking around for this part, make sure you go to Daily.dev. I'm going to do this because I want to either create a group or like experience level. You already know. Highly experienced. No, what? I've suffered enough, nigga. Uh, all right, I think this is the part where we could get back to our normal screen. Alright, TypeScript, npm, Docker, containers, cloud native, multi-cloud, Azure, Microsoft. Hey, LLM, DevOps, front end, GitHub. Okay, so I'm not gonna. I'm gonna come back and select all of it and create a personalized feed. Okay, all right, and boom. All right. Oh, this fire. Okay, so we on Daily.dev. If y'all stuck around all the way to the end, please like, comment, subscribe, and I'll see you on Daily.dev. But my name Kev, Kev the programmer, and we out of here.